Dear students, I welcome you for the understanding of applications of controller in process control. We have already discussed the four different types of controllers used in the chemical process industries, that is the proportional, proportional derivative controller, proportional integral controller and proportional derivative and integral controller. Now, in general, what are the different controlling parameters? That is your temperature, pressure, level, flow rate and composition. These are the five major controlling parameters. And to control these five parameters and depending on the process criticality, I have to decide the type of a controller. That is what the selection of a controller that is to be decided based on its performance. How this controller that behaves. So in general, looking at the figure, the proportional controller there produces the offset and oscillations. Both are there for proportional controller. So the systems in which or the chemical equipments in which one can accept the offset as well as the oscillations, then and only then I can be selecting the proportional controller. In general case, the levels, the liquid level into the tank that can be accepted with this proportional controller, because the liquid levels, they can be slightly fluctuating, they cannot be standstill. So that means the offset as well as the oscillations they can accept for the liquid levels. Now, if there is a gas pressure, proportional derivative controller that can be used, where the offset is accepted but no oscillations are accepted. Variation or the fluctuation in the pressure that is not accepted. Pressure variation is not accepted. That is why we can use the proportional derivative controller. So offset is accepted. 5 kg दिखाने का है प्रेशर तो 6 kg दिखाएगा, that can be accepted, but the fluctuations in the pressure that is not accepted. Then I can select for the proportional derivative controller. Then proportional integral controller. Integral controller में क्या है? Oscillations are accepted, oscillations are accepted, but no offset that is accepted. Means deviation variable is not accepted. जितना चाहिए desired flow चाहिए तो उतना ही desired flow मिलने चाहिए. वेपर प्रेशर चाहिए तो उतना ही वेपर प्रेशर चाहिए. That is what the proportional integral controller, which accepts the oscillations but doesn't accept the offset. That is, for example, in case of maintaining the vapor pressure, maintaining the flow rates, and sometimes the temperature also that can be accepted depending on the process. प्रोसेस जब परमिट करता है मेरे को ऑसिलेशंस, तो ही मैं टेम्परेचर को पीआई में सेट कर सकता हूं. देयर आर सर्टेन वेसल्स इन विच आई कैन control the wide range of or fluctuations in the temperature that can be accepted. But if it's a reactor where I cannot accept the fluctuations or I cannot accept the deviation, there I must be using the proportional integral and derivative controller. That is, the offset and oscillations both are not accepted. That is in case of proportional, integral and derivative controller. So there is a temperature and the composition. Composition also, no fluctuations and no deviation that is accepted. Composition, that should be the perfect one. So this is the, in general, is a criteria for selection of the different controllers.